A very good morning to everyone. I am Srijana, working as an assistant professor from the Department of Civil Engineering, Sasi Institute of Technology and Engineering. The topic that I am going to deliver today is the introduction to surveying. So let's start with the lecture. Surveying is an art of determining the relative position of an object. The objects might be on the earth's surface, above the earth's surface or below the earth's surface. And the relative positions can be determined by measuring horizontal distances, vertical distances, horizontal angles and vertical angles. So this is what the definition that we usually get from the textbooks. So what it exactly means is, if you look at the point, it is the art of determining the relative positions of an object. What we are doing in surveying is, we are just locating the position of object that is on the earth's surface, above the earth's surface, below the earth's surface. Here I am not simply saying we are finding the position. Instead I am saying we are finding the relative position of a particular object. So what it actually means is, if I want to locate this college, which is Sasi Institute of Technology and Engineering, what I am doing is, so this is the college, so I need to locate this college. So based on 3 reference points, I am going to locate this point. Sasi Institute of Technology and Engineering is at a distance of 30 kilometers from Bhimavaram, 20 kilometers from Tanuku, and 25 kilometers from Elur. So this is an example. So based on these locations, I am locating the position of Sasi Institute of Technology and Engineering, this college. So these Bhimavaram, Elur and Tanuku will act as a reference points. So based on the reference point, I am locating the position of our college. So in this surveying, are the reference point that important? Let's see it with an example. So there are 2 points on the surface of Earth, A and B, and I have measured the linear distances between them. And I said the distance between these points is 30. So what exactly 30 is? I mean, is that a 30 meters, 30 centimeters, 30 inches or 30 feet? I haven't mentioned any kind of units. Then how can it be so meaningful? So what I'm gonna do is, instead of saying 30, what I just said is, it is 30 meters. So it is very clear that the distance between A and B is 30 meters, which is quite meaningful. Okay, this meters, which is units, acts as a reference point. So surveying is all about measuring. Like we can see, we measure distances, we measure angles. So in surveying, all we do is we measure the distances, we measure the angles. So surveying is all about measurements. So in order to measure anything, any object, or it might be a distance, angle, whatever it may be, what is main important thing is the reference points. So reference points plays a major role in surveying. So this is what the definition of surveying. So let's move on to the next slide. So where actually do we use this surveying? I mean, being a civil engineer, we must be knowing where the surveying is actually used. So I'll explain it with an example. If a client comes to me and he asks me to construct a building, so I don't directly go into the site and I don't construct the building directly. So what I need to do is, first I need to visit the site. So this is the area where I need to do the construction. So first of all, what I need to do is, I need to go to the site. So I need to select the site which is suitable for the required construction of a building. So second is, we need to prepare a topographical map. So what is this topographical map? So in preparing topographical map, what do we need to do is, if I have an area like this, I need to look around and do a keen observation. There are any kind of buildings, any trees, roads, valleys or mountains or railway tracks, whatever. The complete terrain or the topography of the land should be taken into account. So those details we need to do. What do we need to do is, we need to convert the total ground onto the paper. I need to draw the complete ground onto the paper. So second step is, we need to prepare a topographical map. In the third step is, so after preparing the map, I need to take this map onto the laboratory which I work, like office. I need to take that map into the office, and I need to develop the plan according to the taken topographical conditions. So after preparing the plan, what I need to do is, okay, the plan is completed, so the required building details is done. What I need to do is I need to transfer this whole paper or plan onto the ground. I need to shift this plan onto the ground. This is what the fourth step is. So first step is I need to go to the site and look at the area, and second step is, after looking at the area, I need to make a topographical map. That is, I am shifting ground onto the paper. In the third step is preparing a plan that is required according to the client specifications. And the fourth step is, after preparing the plan, what I need to do is I need to shift the paper onto the ground. So this is what we do before constructing any kind of building. So all of these steps, out of all of these steps, where do we use the surveying? We use the surveying in the step 2. So we use this surveying in step 2, which is preparing a topographical map. We do measure the distances, we do measure the horizontal distance, vertical distance, we do measure the angles, horizontal angle, vertical angle, in order to prepare the map. So the main objective of doing surveying is to prepare a map. So this is where the surveying is used. And let's move on to the next slide, which is the uses of surveying. So as I said, we prepare the maps. What kind of maps do we prepare? So we prepare topographical map, which shows natural and artificial details of the land, like hills, valleys, rivers, forests, villages, towns. So all these details will be shown in the topographical maps. And next, cadastral map. So in this cadastral map, what we get is boundaries of fields, buildings or plots, houses or any other property will be shown in the cadastral map. Whereas the engineering map, we get the details of all the buildings, clear details of every detail will be getting in the engineering map. So buildings, roads, railways, dams, canals, all these detail, each and every detail like reinforcement detailing or the column spacings, everything will be included in the engineering map. Next, contour maps. Contour maps shows the topography of a given land, and it is suitable for roads, railways, bridges, reservoirs, canals, etc. So we next have this archaeological map and some other maps too. So these are the main uses of surveying. So as I said earlier, we prepare maps by using the surveying. What kind of maps are? Topographical map, cadastral map, engineering map, contour map, and military map, archaeological map, geological map, so etc. So we have lot of maps in the surveying. So we are doing or making up maps by using the surveying. So moving on to the next slide. So this is a clear picture of topographical map. This is a cadastral map, and this is the engineering map. As I said earlier, being a civil engineer, we will be mostly using this kind of map, or we will be mostly seeing this kind of maps in our works in the future. So this shows the clear details of every building or routes or roads. Every detail will be shown in here. This is the engineering map, and this is the contour map. Likewise, these are the maps that we're gonna prepare by using the surveying. So moving on to the next slide, we have this principles of surveying. So what is this principles of surveying means? So anything we do, there are some set of rules and conditions, right? So in the surveying also we have some rules and conditions. So what are they? So let's discuss them one by one. For example, I'll explain it with an example. So the reason that I use these many examples while explaining is, surveying is all about the practical knowledge. We can't just directly mug the subject and we write it in the exam. It's not like that. We need to understand the topic and we need to apply the topic into the field. That's why I use these many examples to make you understand. Okay, principles of surveying. First rule, what do we do? What do we need to do? principles of surveying. In the first point we have working from whole to part. I'll explain it with an example. So they have given a land. A client came to me, a client approached me and he gave me a land to survey. So which is of dimensions this. So I have a river, some trees, some buildings, and some road. Example, okay. So what I need to do is, so at the end in surveying what we do is we prepare the maps, right? So this is the land. I went to the site, I have made a keen observation of the surrounding area and I made a little inspection. So I call this inspection as reconnaissance survey. Reconnaissance survey, or in a short form we can call it as recce survey. Okay. So first of all, the preliminary examination or preliminary inspection that we do on the land is called reconnaissance survey or recce survey. So I did the recce survey and what I got to know is I have some trees, a river, some buildings and a road. Okay, this in the given area. What I need to do is I need to shift this ground onto the paper. So I need to make a map of this land onto the paper. So for example, this is the paper. I need to shift this onto this paper. So what I need to do is, first of all, I am marking some points on the ground. This is the original ground, this is the paper. So I am marking some points on the ground. 1, 2, 3, 4 and 5. Not exactly 5, like as many as possible. So and I am drawing or I am dividing these into small triangles, a proper triangles. Okay, this is how I have converted. I have made some points and I have joined those lines and I call this as control network. Okay, so I have drawn a control network on the ground. So I need to, by using the control network, I need to make a map onto the paper. Okay, so these control networks are drawn with very keen measurement, very proper measurement. These lines are drawn very accurately and very precisely by using proper tools. Okay, so this is what I have done. I call it as L1, L2, L3, L4, L5, L6 and L7. So let's start with point A here. Okay, this is the point A here. What I am gonna do is, so first of all I am marking point A here. So now what I am going to do is, by using different instruments or measuring the lengths, this is L7 now, sorry, okay, so I have marked the point A here. So I have measured the L1 length here. Next I have drawn L2, L3, L4, L5, L6 and L7. So by proper measurement, what I have done is I have drawn this complete, I have taken this complete network, control network onto the paper. Oh, okay, this is what I have done. So next what I need to do is, I need to plot this particular tree that I have here onto this paper. What I am going to do is, I am dropping a perpendicular from the tree. I am dropping a perpendicular, and it is not very clearly visible here. If I let me draw it once again. So let me draw it once again. So I have built a control network. So there are trees inside it. There are houses inside it. There is a road. There is a canal. So this is what the land is. So now what I'm gonna do is I'm dropping a perpendicular from this object, from this tree, and I have measured the distance x and I have measured the distance y. So by measuring the x and y distance, this is x and this is y, I have plotted the tree here. So in the same way, I am just dropping a perpendicular, I am measuring x and y distance, I am plotting a tree here. So in the same way, dropping a perpendicular x and y, I have plotted the house here. So in the same way, I am plotting different objects that are present on the land, and I am making the same as per the land. So what I did is, first of all, I have measured the whole area by using the control network. Then first of all, I have plotted the whole area onto the paper. So working from whole to part. So first I have done the whole area onto the paper. Then what I did is I have plotted the parts which are inside the control network. So after that, what I did is I have plotted the parts. So what I did here is I worked from whole to part. I have calculated the whole area, then I have plotted the parts. So this is what working from whole to part is. So what's the main use of this working from whole to part is the accuracy and precision is more and the occurrence of error is very less. So we'll get very less errors through this method and the accuracy is very high in this method. So this is the first working principle of surveying. So moving on to the next slide. And the second principle is we need to look at a new point by using 2 or more reference points. So if you study this, to look at a new station by at least 2 or more reference points. Okay, so if I'll explain it with this, I have Q and P and R on the ground. What I need to do is I need to draw this whole assembly onto the paper. Okay, so I have A, B and C. So three different points. I need to plot these onto the paper. So we have 5 different methods: 1, 2, 3, 4 and 5. So I'll explain it. From the point R, I am dropping a perpendicular and from the point R, I am dropping a perpendicular and I am measuring the x value and y value and I am plotting it. Okay, that's how I plot the point R. In the second method, I will measure the distance L1 and L2 and then I will plot the R. In the third one, I'll measure the L1 and theta 1 and I'll plot the R. In the next one, I'll measure the L1 and theta and I'll plot R. In the last one, I'll measure both angles, theta and I'll plot R. Okay, so in the first step, what I did is I have dropped a perpendicular onto this line. These are the fixed reference points. If you clearly see this, these are the fixed reference points. Based on these fixed reference points, I am dropping a perpendicular, which we call it as offset method. Okay, this is the offset method, dropping a perpendicular onto the line. onto the drainage. Okay, so in this second one I am just measuring both linear distances L1 and L2. In the third one I am measuring the one linear and one angular. In the same way, one linear and one angular. In the last one, the both angular ways. So in this the second one is, in order to locate a new station, there should be at least 2 or more reference points. These are the two main principles that we gonna use in surveying. The first one is working from whole to part, and second one is to locate a new station by using 2 or more reference points. Okay, let's move on to the next slide. Okay, so there is important classification in surveying. There are a lot of classification that are used in surveying on different basis. So first one, if you look at the first one, it is primary classification based on Earth's curvature. Okay, so if you clearly see that, first one is plane surveying and the second one will be geodetic surveying. Plane and geodetic surveying. In plane surveying, what do we do is, we consider the surface that we gonna survey as flat surface. In geodetic, I'll explain plane surveying and geodetic surveying comparatively, so you will get a proper idea. Okay, so in the plane surveying we assume the area as flat, whereas in geodetic surveying we assume the area as curved. Okay, in the plane surveying we assume, as I said, the curvature is neglected. Earth's curvature is neglected and the area or the surface is assumed to be flat, whereas in geodetic surveying the Earth's curvature is considered and it is in a curved portion. Okay, if I draw a line or if I connect any 2 points on the line it's gonna be a straight line. Okay, if I do connect any 2 points on on geodetic surveying, what I'll get is, I'll get a curved line. So in plane surveying we get a straight line if we join 2 points. In geodetic surveying we get a curved line when we join 2 points. And if I draw a triangle, in plane surveying, what I get is, I get a plane triangle. If in geodetic surveying, what I get is, I get spherical triangle. A, B and C, A, B, C. Okay, in plane surveying I get a plane triangle. In geodetic surveying I get a spherical triangle. And the plane surveying is done mostly for the areas, like smaller areas less than 250 square kilometers. So the areas with more than 250 square kilometers, we do geodetic surveying. Okay, so this is what plane surveying and geodetic surveying means. So if you clearly look at the points, horizontal and horizontal distance and angles are projected onto the horizontal plane. And if we draw a line in the planes, if we draw horizontal distance and angles are projected onto the horizontal plane, and if we draw straight, if we draw a line onto the plane surveying, we get a straight line, whereas in geodetic surveying we get a curved line. And if we draw a triangle in plane surveying, what we get is, we get a plane triangle, whereas in geodetic surveying we get a spherical triangle. And in plane surveying we do the surveying only when the area is less than 250 kilometers square, whereas geodetic surveying when the area is more than 250 kilometers square. So this is what plane and geodetic surveying means. This is the classification based on Earth curvature. In plane surveying we neglect the curvature of Earth, whereas in geodetic surveying we consider the curvature of Earth. So this is geodetic surveying. Okay, as I said earlier, these are spherical triangle and this is a plane triangle. This is plane surveying, this is geodetic surveying. And we have another classification. The classification is based on function. If we do this topographical survey, we'll get what do we do get in surveying? I mean, what do we do in surveying? We prepare the map. What kind of map do we get in topographical surveying? Of course, topographical maps. Okay, so what do we see in topographical map is the natural features and the artificial features. Natural features means hills, rivers, valleys, etc. Artificial features means like buildings, railways, roads, etc. So we, in order to draw a map of topographical map, we need to do, what we need to do is we need to do topographical survey. This is what the classification, and this is the pictorial, this is a picture. And next, cadastral survey. So I have a building, I have two different building and empty land, for example. I need to get the boundary lines or property lines or the borders of this particular buildings. What I need to do is I need to have cadastral survey. This is the view of the cadastral survey. So this is conducted to determine the land boundaries, property lines, land area. Okay, so this is done in cadastral survey. And next, city survey. In city survey, it is conducted for town planning and urban development, and it is mostly used for the drainage systems, water supply, roads, etc. and for building layouts too. Okay, this is engineering survey. It is mainly conducted for planning purpose, engineering planning, design, construction of engineering projects, and it is used in the buildings, bridges, dams, highways, etc. So these are the pictures of it. And this is a route survey. This is mainly used in the alignment of roads or railway tracks. Like if you see conductor along, it is conducted along routes or alignments. So this is mainly used in roads, road alignment, railway alignment, canals, pipelines. For all of this, what do we do is route surveying. Okay, moving on to the next slide. This is hydrographic surveying. It is done in the water bodies. It is mainly used in harbors, navigation, and in order to measure the depth of water. And next, military survey and geological survey. So that's the classification based on the function, whereas next classification is based on instrument used. The classification that is based on instrument that we use in survey while doing the surveying. So the first classification is chain surveying. If we use the chain, so this is the chain. So if we use the chain for doing the surveying, we call it as chain surveying. So chains, if we look at the definition, surveying in which only linear measurements are taken using a chain or tape. In this, we will not be able to measure the angles. Instead, we will be able to measure the linear distances only. So we use different instruments. These are the instruments used, and mainly this is used for smaller and level areas. If we have undulations like ups and downs, if we have ups and downs, we will not be able to use this chain surveying. Only when the surface is flat, we will be able to do the chain surveying. Okay, and the main advantage of this is it is simple and it is economical. Okay, this is what chain surveying is. And this is compass surveying. Most of us have seen these in the movies, right? So while traveling in the oceans or seas, most of the people will carry this compass in order to know the angles. I mean, like are we facing the north or south, which direction we are facing. So in order to know that, we do this compass surveying. So if you clearly see this surveying in which directions are measured using a compass. Okay, we use instruments, and what we do get is bearings and distances. Bearings are nothing but angles. Okay, and this is done for areas with irregular boundaries. So this is the second classification. And next, plane table surveying. It is plotted in is done directly onto the field. We don't do it in the office or the laboratory. What do we do is we will go to the area that we gonna survey, and we do this plane table surveying. So instrument used are plane table, alidade, tripod. The main advantage is it is very fast method, and the accuracy is also more in this. So this is the pictorial. This is the picture of the plane table. Next, theodolite survey, very important one. So we'll be able to find out the horizontal and vertical angles by using this theodolite. Okay, being a civil engineer or being an engineer, you will be using this instrument, and it is very important for any kind of engineering works, especially the roads and bridges. We will be using this, and it is very highly accurate. So this is what theodolite is. This is the theodolite. These are the parts that explains the theodolite. Okay, next, this is leveling. It is used to find the elevations in the sense the vertical distance. Okay, the height or the vertical distance between two objects is known as leveling. So elevation. So elevations are found by using the leveling. So we use different instruments, dumpy level, leveling step, and main uses are road. It is used for the road construction and the drainage works too. So this is what dumpy level looks like. And next one, we have tachymetric surveying. This is it measures the distances and elevations too, and it is way more faster than the chain surveying. It is mostly used in the hilly areas, and it is used for making the contour mapping. Okay. So next, electronic surveying. We use total station, GPS, EDM, all these will be used in the electronic surveying. A detailed lecture of these topics will be discussed in the upcoming classes. So this is all about today's lecture. We have so far discussed the definition of surveying, the objectives of surveying, uses, principles of surveying, and the classification also we have discussed. In the upcoming classes, we will be discussing more about the surveying, and that's all about today's lecture. Thank you.